I want to talk to you a little bit about the embedded computing hardware that you find on an embedded system. Recall that there are many different kinds of developer embedded systems out there. We picked the Arduino Nano 33BLE. I want you to understand what are the pros and cons and what are the trade-offs that we are making here as we are going down to TinyML. By and large, when you look at the class of processors that are out there, there are many different types of processors. And I'm going to talk specifically about the ARM Cortex profile. The ARM Cortex profile of processors are widely used in mobile applications ranging from smartphones all the way down to small little microcontrollers that we find everywhere. So by and large, there are three tiers, I would say. The application of processors that you find in things like smartphones, for instance, are capable of running complicated tasks. So you have these application-grade processors. Then you have real-time processors that you tend to find, for example, in automotive vehicles, in machine operation systems, and industrial automation. And then you have microcontrollers that are pervasive, and you tend to find them everywhere to interface with sensors and to do local processing and actuation. Now, all of these tiers come with many different variants in each tier. For example, the application processors go from A5, A9 to A15 and so forth. One of the reasons that you tend to have these tiers of processors is because you really are trying to look at the shape of and how to shape the power off. So for example, we go from application processors that consume anywhere between 3 to 4 watts, where you come down to microcontrollers, and these consume something on the order of 10 to 20 milliwatts. And what's the trade-off? Well, you simplify the functionality. By reducing functionality, by limiting their ability, you actually lower the power down. Why do we care about having low power? Well, it's because it's TinyML, and we want tiny machine learning to be running on coin cell batteries at all times. And therefore, we're trying to focus on microcontrollers. And that's why in this particular course, we're going to be using these small M-class microcontroller processors. Now, in addition to just sort of understanding that piece, the lay of the land, so to speak, I also want you to understand what are the differences, within the microcontroller space itself. Even in the microcontroller space, there are extremely low and simple microcontrollers like the Cortex M0 that you're looking at over here, which is capable of doing general data processing, general input-output control tasks, very, very simple stuff. Then you might have the M3, for example, which is a bit more advanced doing and can do more data processing because it has an instruction set architecture and the instructions set to support things like bit manipulations, which allow you to do arithmetic a bit more efficiently. And it also has like DSP capabilities for digital signal processing, and that you can actually execute multiple instructions as one instruction. And then you have something like the M4 that we will be using, which has a floating point unit, which allows you to do floating point arithmetic on the device, which is a great thing to have, especially when you're dealing with things like keyword spotting and other types of TinyML applications, where we might have to do a little bit of complicated math under the hood. So the bottom line, that I'm trying to say here is that, you have this small microcontroller that we've chosen. It's got all the fundamental nuggets, being limited in terms of its performance and memory because of the power efficiency that we get from it. And it's something that you actually find, in the examples of devices like in the Echo Dot that we did a teardown of earlier. Now, in addition to this, there are a couple of other things that we need to touch on, such as what is the software stack that actually enables these embedded systems to run code efficiently on? And I'll see you there next.